And we're live. Welcome to another episode of Interchain FM. We are here with Greg Osuri from Akash Network, a public blockchain built on the Cosmos SDK for decentralized cloud computing. Welcome, Greg.
Thanks, Django. Great to be here.
Yeah. Do you want to give a quick intro and then tell us about how you got into Cosmos?
Sure. My name is Greg. I am been a programmer for a little over 25 years. My background is applied economics and computer science. I would say like last 10 years, I've been primarily focused on building and shipping developer tooling. I founded a company called AngelHack. I was really with a mission to take hackathons, which were a very underground concept back then in 2011, to more mainstream, and had an amazing opportunity to interact with a lot of developers. Helped launch a few companies at AngelHack, a big one being Firebase, which eventually got acquired by Google. One common pattern I've noticed amongst developers, especially developers under duress, is deployment, right? So you write your code, and what happens after that is usually tend to be a bigger points of friction. So I decided to focus on that, and got involved really early in this nascent technology back then called Linux containers. Kubernetes happened to be a platform that was sort of like just kind of launched and grabbed my attention. So I ended up contributing and using the platform quite a bit, and formed a company to take Kubernetes to market in 2015. Before, not too many people heard about Kubernetes back then. I believe right now 80% of the cloud uses Kubernetes. So got involved into that really deeply. And as we were deploying, and Kubernetes is this thing that you can run on a data center, it gives you this amazing capability to manage your clusters in a fault-tolerant, in a scalable way. And a common pattern we noticed while we were deploying these solutions were the efficiency was significantly lower than what we thought. And that was one of the reasons why people wanted to go to the cloud. Around 85% or so of compute that sits in these data centers remain unused. In some cases, even 95%, right? And the reason for that is peak, planning for peak. You need compute to handle peak loads, but peak loads only happen maybe 1 or 2 days in a year if you're lucky, right? So there was this amazing capacity that's sitting out there, and on one hand, and on the other hand, you have these sort of like companies called cloud service providers that are gaining market share by selling compute at a premium. So there's obviously a huge gap here, a huge imbalance. That's when the idea for Akash Network came around to create a marketplace. This is in 2016 that unlocks this unused capacity, and we had the technology that we sort of like built to unlock this capacity, and that's the genesis of Akash. And when we were designing the solution, we established that it has to be an open source offering. It has to be a marketplace. So that kind of put a few things at odd because we don't really have open source marketplaces. And that's really where we wanted to do this in a peer-to-peer manner. We designed the early version using a BitTorrent style replication with a Merkle tree style integrity for data. And we adding trustability on top of that. We ended up with a blockchain. So we kind of like built our own, I wouldn't call it a blockchain, but our own like whatever chain. And then 2017 hit, we were, obviously the chain needed a lot more work than we could actually afford to. And then we were like, well, this blockchain thing was kind of like getting to maturity to a level that can be usable. And that's when we decided to do blockchain. And we were looking at solutions back then. There weren't really anything. Ethereum was the only one that had some that was live, and we kind of like played around with it. And then we saw CryptoKitties and how that went down. And then it was not a thing that we could build a scalable cloud platform on. That was obvious. We built an early prototype on Ethereum. Ethereum, by the way, is great for prototyping. It's quick and dirty, right? So, and then when we decided to actually do this in a scalable way, Tendermint was very appealing because it was number one, Golang. So since it was Go, we can actually go and fix things ourselves. We've been a Go shop from the beginning. I've been a Go programmer since 2014. And second, it was a library format, so we can actually, use, and we can actually control the scalability narrative and the economic narrative, right? And third, the team, it had very similar sort of like characteristics of what I see in successful open source software, in terms of pragmatism, in terms of the cadence at which updates are done. There's a lot about it which resemble early days of Kubernetes and early days of Docker. So that was very appealing. And this was still in Tendermint land. And, so that we ended up building a whole lot of code on top of that, all the banking module and everything from scratch, basically. And obviously that wasn't, and then we had this Cosmos SDK project, which was kind of developing on the side. It wasn't ready, at least in 2017, for us to start seriously looking at it. But then we shipped our second prototype, and Tendermint had its own issues. 2018, 2019, we decided to migrate to Cosmos. There was a master PR where we got rid of 200,000 lines of code or something, something ridiculous like that, because we built all that. And ideally for us, is the best case scenario for us is to write less code. So that's less attack surface. And we'd rather have more shared code, which is obviously has much better scrutiny in public, and because it's used by a wide range of consumers, it's better. So for us, the goal is always to have less code as possible. In that vein, the modular architecture of Cosmos was very attractive, and we migrated from Tendermint to v.1 to what Cosmos is today, and now Akash Codebase, I believe, is on 4.2, Cosmos 4.2, which is the latest and the greatest, and very soon we should have the hub connectivity figured away. So I know it's a long-winded, history lesson, but
no, great, yeah,
that's how we ended up with Cosmos.
That takes us through, most of the background. Did you foresee your solution being the perfect solution when Tendermint came out with its Sentry node architecture?
For a solution for what? For
validating using Akash.
Using Akash to run Sentry nodes?
Yeah.
Oh yeah, we didn't really design Akash for blockchain per se, right? We ended up with attracting a lot of blockchain nodes because it was a very natural alignment in values, and
right.
And so Akash, the platform right now offers significant advantage when it comes to cost, censorship resistance. It's a self-sovereign platform, and it is essentially permissionless. So it's very attractive to a lot of folks in the space, especially folks like they want to stay anonymous and they like their privacy, like Thorchain folks. They don't like to put their credit cards on Amazon.com, right?
Yeah, totally.
So that's and we have a lot of users right now that don't really like the big guys, the Amazons and Googles and Microsoft for obvious reasons. And so Akash is very attractive. On top of that, right now, some of the users are getting 8 times lower costs than Amazon. Like Amazon Fargate, a half gigabyte box, and Fargate to cost about $16 a month. On Akash, it costs about $1.80 or something like that. So it's very attractive. It's cheaper, it's faster, and it's censorship resistant. No one can stop you from using Akash, even I can. So,
can you walk through the basic flow of how the two sides of the market would meet each other in this marketplace? So how buyers of compute power would place bids, I assume, of some sort, how sellers would match those bids, particularly with regards to what kind of assurance is provided by the protocol, seems like through interactions with the blockchain, as to the compute being done correctly, on time, as requested, etc. Because without, I presume you're not using zero knowledge proofs of the compute itself or something like that, so you probably have some kind of scheme to ensure that if I request some program to be run, I can verify that it got run in a way that is cheaper than actually executing the program myself, right? So
sure. So I'll walk you through the flow first, and then we'll go into verifiability. So from a user standpoint, the first touch point is effectively you need a container. You need your application to be running in a container, a Linux container, and hosted in a registry. Once you have that, you use a declarative language that we created called SDL, where you define your workload, the placement parameters, the different attributes you're going to filter out the workload for, like location and whatnot. And of course, you set the price and as to how much you're willing to pay, and you place that on the order book, and providers bid on it in essentially a reverse auction model, and then you get to make the final call. I mean, it doesn't really pick automatically for you as to which provider you want. There's a little interactivity that happens there, which can be easily automated as well. That's up to the user, but we wanted to keep as much the decision cycle away from protocol as much as possible. And once you establish once a bid is won, a lease is established, and that's when the assets are transferred, your deployment assets essentially, and then you get an endpoint for the ports that you want to access, and IP address and whatnot, and then from there on you essentially put it on a DNS. Now, Akash is not a verifiable compute platform. It doesn't have verifiability, but rather it depends on reputation, right? So the reputation system we have in Akash is something we call audited attributes. Now, providers can provide any attributes they want, essentially their location, their compute they're willing to offer, and a third party, a trusted third party, will audit those attributes offline and signs them and places the signature on chain, and you can essentially trust this third party and thereby trust this provider. It's very similar to how today you establish trust with Amazon or Equinix's by their brand, by their website. In a very similar way, Akash audited attribute, the auditors has to give you that capability to trust. So it is not a verifiable compute platform, right? Essentially, that opens up a lot more opportunity for us, because now, if you think about Akash on Amazon, the best analogy I would give for you is Airbnb versus Hilton, right? So Amazon, if you are someone that wants a consistency and that you want limited sort of options, and you want that experience of going to a Hilton in Delaware to a Hilton in San Francisco, you get the same coffee. That's really that's what Amazon for you is. Whereas Akash, you get all kinds of exotic options as the network goes. Now we're looking at providers such as transit providers. They'll give you latency speeds up to like 5 milliseconds between LA and San Francisco, right? And you have all kinds of, now we're enabling GPU marketplaces. You get all these like different architectures from GPU arrays. You get different RAID setups, and you get all these massive set of attributes that most of them cannot be verified cryptographically, right? So that's really how you look at Akash from a verifiable compute platform versus a reputation-based platform.
And how do you scale?
It's horizontal, depending on the applications. We don't really care. Are you talking about applications, or are you talking about blockchain itself?
The blockchain itself. So, for example, let's say you've reached critical mass, and you expect to still be faster than Amazon and cheaper. Is that sustainable?
Oh yeah, I think the cost is definitely sustainable. So Akash compute doesn't run on chain, right? So Akash compute runs off chain. So the scalability is as big as the data center can scale. And right now we have Equinix Metal as the biggest data center provider, the biggest interconnected data center network in the world. I mean, they provide compute to Amazon itself. If you want to transfer one region to another region of Amazon, you use Equinix. So they are providing compute at significantly lower cost because they want to offload the legacy sites, which what Akash is really good for, right? And we have about 8.2 million data centers that have enormous amounts of unused capacity that wants to offload. And we have amazing like opportunities with the Ethereum, network coming off GPUs, coming off proof of work and going to proof of stake. That opens up a whole range of GPUs on the market. So that's significantly helpful for AI workloads. So the cost is, if you look at the cost and look at the Akash model, which is essentially a function of demand and supply. With more supply, you can do the math, right? So from a scalability standpoint, it is as big as the underlying data center can scale. So, we're pretty confident, Equinix has all the resources and other data centers that will onboard. And it's permissionless, so anybody can come and list their compute, right? And second scalability factor would be the design of the application itself, right? We don't get into the application design. The developer is fully responsible as to how they want to architect their applications. Now we have stateful workloads that require something like the blockchain, right, where you really can't have parallel processing for a transaction. That becomes a little challenging to scale. But if you have something like a distributed system, a typical distributed system that can scale horizontally, yeah, your money is your limit, essentially.
And what goes on the blockchain? What kind of data goes on the blockchain in that case?
Only the order book, the order data. So it's very minimal. The prices, the order data, the verifiable compute, the audited attributes, a very lightweight data set. And of course, your transactions and whatnot, your typical stuff. But so it's a light data set.
Okay. And so how do you imagine people using IBC once that's enabled?
Right. So this is where it gets really, very, really attractive. And this is our vision for a interoperable cloud. So today you go to Amazon, there are about 200 services that you can use and you pay using a single credit card, right? And you kind of need managed services if you want to build something very scalable, right? And you can do it yourself, but the amount of time you need to sink in to manage these services is not very scalable, like a human capital scalability standpoint. For example, on Akash, if you want to deploy a database, for a decent application, you probably need a database. You probably need you definitely need a state store, right? You do need a KMS, or you definitely need a DNS. You do need an object store. You do need a lot of these things Akash doesn't provide. So you have two choices now. You can either install them on Akash and manage it yourself, which takes time and energy and resources, or you can use an external service, ideally, which is decentralized, right? So if you want to use Skynet for object storage, which is great object storage, Akash doesn't provide object storage. Or if you want to use something like Handshake, you got to go do the integration yourself today and pay using the individual tokens. So essentially, it's equivalent to having like 10 credit cards to use 10 services, which is not very practical, right? Ideally, we want a world where you can pay using any of these currencies and interoperate with them in a much sort of like frictionless way with a cohesive user experience, with a very unified user experience. And Akash has this beautiful language called SDL file where you can declare what services you want and you should be able to pay using that, right? So that's why we are very serious about IBC being a solution. What I love about IBC is just not about transfer of value, but it's actually a deeper integration or deeper interoperability model where it's actually transfer of different types of transactions, right? You can actually integrate and make effectively a atomically composable world, right? So between different blockchains. So that's when it gets really interesting. I think that's when we can unlock a lot of the adoption. When someone can use a decentralized cloud without having to do any logins and doing any of this nonsense that you had to go through, right? All these hoops you had to go through today to use the cloud. So IBC is going to be a very important element in Akash's future.
Yeah.
And
do you imagine
the first value is liquidity? And there are lots of different projects that are actually looking at providing liquidity to AKT, the Akash token, through IBC in the early days. But hopefully that'll branch out to a lot more interesting use cases.
You kind of hinted at the decentralized web narrative And that's really interesting, which is maybe you imagine that Akash might be an interoperability layer for all these different decentralized web solutions and integrate each of them for this seamless user experience. For example, if in the future there's decentralized web, and maybe I could use my single sign-on with like a handshake name or something into Akash's decentralized cloud, and then I could, host my own email or something, whatever I would otherwise do with Amazon, and then I would, have storage on Sia or IPFS or something, and that would be great. And so
Mhm.
all of that without ever touching an email that somebody else owns or a hosted cloud that I have to sign on and like verify identity with my phone number or something that's super insecure.
Exactly. That's exactly where we want to go, right? We don't collect a single thing, no identifiable information. It's not secure, right? So we don't need PII information to run a website. There's absolutely no need for it. So in ideal world, you want to see a Uniswap style, like exchange of value, not a centralized exchange style.
Yeah, totally. Do you imagine this to be somewhere in the near future, or is it something that's like so far away that nobody right now cares about, and they're thinking that, okay, well, I have Amazon services and it's fine and it works, just kind of having the same mentality as somebody in 2009 would say about the US dollar?
I think we're going to see a demo in the next three months. I would say like
3
even
months,
3 weeks, maybe
3
even
weeks.
3 weeks. There is someone that's working on integrating Skynet and Akash because that's sort of like a marriage made in heaven. We need storage and they need compute, right? Like
Yeah.
we both need each other. Someone's writing a WordPress website on Akash and storing the data on at least the snapshot on Skynet and running the MySQL and loading the snapshot from Skynet. Someone's working on it from the internet. I saw yesterday.
That's very exciting.
And I think they're also connecting a handshake where you can actually use a handshake domain name. Well, the thing about WordPress is that you can only have one domain. God knows why they have that design, but I guess so. It'd be cool to actually see a handshake dWeb only WordPress installation where all the components are completely dWeb. This is like a Web 2 kind of like coming to Web 3 kind of world,
Yeah, totally. One isn't enough without the other. Like one is incomplete, right? Like Akash or Sia or handshake alone can't be an island of its own. It's not like a full solution, but and together it becomes this beautiful marriage that's going to.
That question, can all of the matchmaking process be automated? As in, could I create another application on another blockchain which requires Akash or compute resources leased over Akash, and in order to lease those resources, sends IBC messages from my application to the Akash chain, which provide appropriate build configurations or deployment configurations and sufficient instructions that like the bidding and selection can happen automatically, because I don't even want user interaction, right? Like, let's say I want some contract on another chain to be able to trigger this kind of blog deployment or decentralized blog deployment automatically. Is that possible?
Oh, 100%. I mean, everything is a transaction. The reason why we remove decisions out of Akash is so that the consumer, the user of the network can have the power. It could be a machine or it could be a human being, right? 100%. I mean, we kind of kept as loosely coupled as possible from the decision making capacity versus just pure resource allocation capability. We'd love to see that sort of the IBC being the enabler for such cross-chain like resource provisioning, and because Akash is really fast, it's really good for ephemeral and rapid provisioning and deprovisioning of workloads.
Really fast, as in what kind of throughput are you getting?
From the blockchain, I think we didn't really do a full test. I mean, well, the last one we did, I believe we were getting, we did like 300 TPS because we had a DDoS attack. But someone else did a full throughput. I don't remember the exact numbers, but 300 TPS is plenty. Yeah.
That's pretty good. So, yeah, sorry, a little bit of a right turn, but I wanted to ask about that pancake swap and cream finance DNS level attack, right? So, nothing was really specifically disclosed about that, but you could kind of infer what might have unfolded. So let's talk about that.
Yeah, if I remember correctly, was the attack basically a social engineering thing from GoDaddy where they, they call and pretended to be these people and change the DNS records? That's what happened, right?
Okay. Well, I didn't hear follow up about that, but it sounds right. So if it's a social engineering thing, it sounds really similar to this infamous attack that happened to a user who held the Twitter username N. Did you hear about that? That was like in 2014, right? It's like the weakness in all of their security measures tends to be from socially engineering, like an employee of GoDaddy or PayPal or something, where like you just pretend that you've lost your credentials, and then you get them to repeat to you like a piece of identifying information, and then bam, they get access to your GoDaddy, they get into your registrar, they point your MX record to their server, and now they've gotten into your email, and now you're just like SOL.
Yeah. I mean, it's 99.99% of the attacks happen that way. It's because of human error. It's very hard to like actually break a DNS server and hack into that record set, right? So that's exactly what, if I remember correctly, that's what happened with Pancake Swap and a lot of these. So GoDaddy was compromised, and it happened to me actually. It was 2018. My phone had a swim swap attack, and somewhere down like an option in my 14-year-old Gmail account, I forgot to uncheck that you can recover using my phone, and that they abuse that. I highly recommend people go uncheck that. Even though most of my stuff was on a 2FA on a hardware. So these things are human errors, and a lot of that times it really comes down to like how much control you have in your life, right? Like what crypto, the narrative really is about control of your keys and control of your destiny. If in that case, like what happened to me or what happened with Pancake Swap, ideally I want to have these keys basically have the final say. Now I'm saying not going to guarantee that if you lose your keys you're going to have that control, but at least now I have the responsibility and I have a lot more transparency and a lot more freedom as to how I want to secure my life, right? Now, if you're giving your private keys away, again, you're not going to help much. But yeah, so it really comes down to the sovereignty side of things. I'd rather have the control on me versus a GoDaddy employee or a Facebook employee or a Google employee.
Yeah. Unfortunately, a lot of users would prefer convenience over security. But at the same time, if we're entering into this dWeb phase, do you think that users will eventually have to trade off convenience for security, or will convenience mature to such a point that it's just going to be like the same experience and it's more secure?
I mean, I think people should have the choice, right? Right now, you don't have the choice. Right now, it's all controlled by someone else. You really don't have the choice. Like, you can't go to your bank and be like, give me my private keys, right? So for people that want to trade convenience for security, so be it. They can until you get hurt, till something happens to you. But understanding that you're giving this trade-off is what's very important. I think the real fight is to have it be this transparency, right? As to like who's handling my funds and how is my privacy being handled. So people like us, I mean, we know better than to trust anybody, right? Like I'm not going to trust anyone with my money or with my data. But like my grandmother, of course, she's not capable, and she rather have a trusted third party, right, do the thing for her. So I think let the market decide that, not have someone else decide what I want. And yeah, you're going to see custodial services. And I think it's going to be a big market, no doubt about it. But I think they're going to be like all different types of custodial services. I think having a free market for custodial services is as important as having the sovereignty for people.
Yeah, totally.
Because the worst thing is to have someone that has no idea on how to secure the keys, secure the keys. And I had a friend of mine who sent me a picture of his private keys seed phrase in a text message. I was like, no way. People do that, right? Like,
oh gosh, yeah. So long time ago, I know somebody who took a picture of their seed phrase and it automatically uploads to like Apple Cloud and then there you go. Yeah. Somebody who can hack into your Apple account can get access to your seed phrase.
And all they need to do is like image recognition, algorithm, and they can get everything. And what's worst is, I don't know how many people know this, and do not use iMessenger ever. It's really bad. If it stores in plain text on a computer, like plain text, a text in some directory, all the images, all your messages. So if anybody were to get access to your computer, which is not that hard, they can actually download this entire database, and then you're done.
Mm-hmm. So in the future, can you tell us your vision about the dWeb and perhaps walk us through a user story where somebody who is using all the features of the dWeb can go through?
Yeah, I think like my vision, like I said, like a fully interoperable dWeb, right? So ideally, all the data centers, all the GPUs, and all the home devices, anything that can spare extra compute cycle should be available to a market that can use, including Teslas, right? Teslas are essentially like data centers on wheels. They have 200 computers, and they're not being used in the evening, and they're being charged. Imagine unlocking the GPU capacity, right? Like you can run Akash right now on a Tesla.
Are you saying that in the future, your Tesla is going to be able to mine Akash for you?
100%. Yeah, there's no reason it shouldn't, right? Like in the night, you're having 200 GPUs go to waste while you're charging, right? So it 100% should mine or like offer their compute to an AI supercomputer that wants to research, I don't know, weather patterns or whatever. Imagine connecting all the Teslas and creating a supercomputer to analyze weather patterns, or like scientific research or whatever you want to do, right? That's a very powerful set of computers we're not using right now. And maybe even pay for the Tesla itself, earn enough to actually pay for Tesla. So it creates incredible amounts of efficiency, just like the solar grid you're seeing, right? I think if we solve the efficiency problem, we'll bring down the cost of compute so much so that it becomes like a second nature. And what happens when you can bring the cost of compute to a level that we don't have to think twice about doing any AI work. I mean, the biggest impediment for AI right now is the cloud. It's really bad. Anderson Horowitz came out with a report indicating that about 20% of the companies that do AI, their margins go to Amazon. It's ridiculously expensive, and blockchain is not helping by eating up all the GPUs, right? So it's incredibly crazy demand for GPUs, and the Moore's law is not working out the way it's supposed to work out. So all that is like just complete bullshit. So it's very, very expensive right now. So once we can essentially unlock that, bring that to a decentralized web, I think we're going to see a whole lot of new use cases that we can't imagine. That's the thing about future; you can't really picture it.
Yeah, that's actually extremely exciting to me, and I've never connected those dots before this interview. But now you've made me want to buy a Tesla.
So I'm going to buy a Tesla to hack on. Maybe put my Akash name. Akash works really well on a ARM board too. So
forgive my naivete here, but I thought that the margins on cloud or like the competition ended up being on cost efficiency or like electric uh, power consumption efficiency
Power.
of compute.
Yeah.
Do you think that insofar as much of the underutilized compute which would be enabled by this kind of marketplace is not primarily intended to serve in this role, or at the very least has other constraints informing parts of its design, do you think that it would still be able to compete on power efficiency, or won't the margins just be driven down to some point where, like, then all of this auxiliary compute is not even, just like old Bitcoin miners, is not even worth paying the electricity bill for?
So it's all on workloads are not equal, right? So it really comes down to the type of workload, right? So like GPUs are so different from CPUs. ASICs are a whole different animal. From a GPU standpoint, there is, it really comes down to like two categories. Like one is for profit. You're actually having these mining rigs and you're offering, and the economics are, they're very, very hard to break profit, right? So unless you're doing a hyperscale data center, you can't really make money. And I think the fill rate, if I remember correctly, had to be 80% or so in order for you to break profit, right? So 80% of the time you need to be selling these compute. So obviously, if you want to lower cost, you can go build a hyperscale data center to compete with Amazon, right? And that's a whole different animal. So the only way to really bring down the cost is to go with unused GPUs, right?
Mm-hmm.
So with CPUs, it's a little different ballgame, right? So with CPUs, I think it comes down to it's not extraneous in terms of your cooling capacity that you will need for GPUs. And with CPUs, it's the fill rate, I believe, was like 20 or 40% requirement for a data center in order to turn a profit, which is a lot easier for smaller entrants. That's why you see a lot of smaller providers, about 4,000 cloud providers in the world. People you never heard of, like 6x7 and Orion or these guys, right? So all of them have very low utilization. They love to get more utilization, and they're still manage to keep the lights on. So of course your low latency workloads such as web workloads are very optimal on CPU, whereas whereas message passing style of bad jobs are great for GPUs, right? So that's really how the economics work. And yes, you're right. Like, it's very hard to turn profit on a GPU farm unless you're having a very, very high utilization. That's why I was really excited about this like unused capacity. And if you look at what AI companies do right now, is they tend to bring in GPUs into in-house running their own clusters just to address this cost problem, but they only end up using maybe 2-3 hours a day. And I know a ton of companies that do this, 2-3 hours of training. And most of the time they're not using. In a case like that, they could actually install Akash in their clusters and sell the unused capacity back into the network, like a power grid model, and earn tokens for that unused capacity. And when they want to use at peak, in which they normally actually hit their peak levels, they can use these tokens to sort of like, compensate for to pay for compute. So in this case, the provider itself becomes a payer, and that's really an ideal peer-to-peer GPU cloud that we really want to target. So the economics are not about making a profit, but rather reducing the cost if you are the user. That makes sense.
I'm taking some questions from the audience right now. Ismail Molotkovsky asks, when can we see Akash on IBC?
I think we have, so we have an upgrade that that is approved, and it should be live this Friday, I believe, so tomorrow. And after that, it has an IBC bug. I don't know how familiar the issues, right? So we couldn't risk sending the update IBC enabled proposal without this upgrade happening. So after this, we'll send another proposal to enable IBC transfers, and then it should be live in 2 weeks. It should be ready, and I think people are going to connect to it. So let's to put a timeline 2 weeks from now.
Sully Henderson asks, what safety is there in the future as far as bad actors using Akash to host their content?
To bad act. So you're talking about bad people hosting bad things in Akash. So that remains a challenge, right? So providers are ultimately responsible for moderating their content. So that the Akash doesn't really play any part in moderation or censorship, but we understand that people need the freedom to choose who they want to host, right? So we probably will help people, filter out bad actors, and especially they have to, like big companies like Amazon, or maybe even Equinix have their tooling to filter out anything crazy bad, right? So there probably are going to be tools out there to help you filter out, but that's where we are. That's the price of censorship resistance and free platforms.
I guess my understanding of Akash was that like anybody could provide hosting and compute, right? But your answer implied that they are identifiable and that they can do content moderation.
They're not necessarily. So we have this audited attributes mechanism, and during that they're identifiable, right? But if they don't have to have their attributes audited, anybody can provide compute in a permissionless way, right? But if you're hosting a compute, if you know the IP address, you can associate the IP address technically if you have the tools to a container that's running on your computer. The IP address is serving some child pornography or something, like, you will be, you will have a visit by people, right? And you probably don't want that on a computer, right? So we're not going inside when we can easily, you should be able to like not serve that, right? Like, but if this is going to be a political thing that you probably want to support, then you don't need to sort of like remove their content. So it's up to the provider to decide what they want to host or not. So what Akash does is, if a provider kicks you out, the workloads go back on chain for another provider to pick it up, right? So as long as there's a provider that wants to host you, your application doesn't go down. But if all the providers don't want to host child pornography, it'll go down, right? So the system is designed in a way to like propagate responsibility to people using it versus someone else deciding what's best for everybody. It's really the people that will decide what's best for them. That's how we look at censorship.
So it's this network of hosts who decide whether or not to propagate certain data to the rest of the network.
No. It's a peer-to-peer relationship. Like, so if you have 100 providers on Akash, hypothetically speaking, right? 99 of them choose they don't want to host you. They don't, but the one person choose to host you, they can, and your application will be alive, right? But all 100 of them decide like, no, this is something we don't want to touch. No one's going to host you. But if there's a 101st provider that comes in a permissionless way and they decide to host you, they can. So as long as there's somebody willing to host you, the system will accept you. If there's no one that wants to host you, they won't. Like, so that's to give you a best analogy. If you go to Reddit, right, and you post something, and everybody's going to downvote you, then it's going to go down. The more people upvote you, it's going to come up. But unlike Reddit, where Reddit can decide to shut you down, Akash can't.
And so if all the hosts decide to censor you, then you say, okay, well, I'm going to become a host.
Sure.
I'm going to host myself.
If you have a computer, connect to Akash and become a host. Yeah.
Got it.
And there's no limit on hosts. Anybody can become a host.
Yeah, that kind of reminds me of so we had an interview with KyoCon a couple months ago. They were building a peer-to-peer network called Footnote. It reminds me similarly to that, but it's more like a storage network. But it's where if you a client on your computer wanted to propagate some data, you could. But if you didn't want to see specific information like child porn, for example, you could block it yourself. So then the responsibility is abstracted away from the hosts and onto like the individual who's like looking at the information.
Right. So we don't give you that level of sort of like tooling, right? We can't say block. The Akash software doesn't support any looking into workloads, right? We can't do that. We don't want to do that. So the responsibility comes down to the people. I believe the community will develop tooling. We maybe will assist in development of the tooling for self-moderation, but yeah, the Akash platform is very responsive at this point when it comes to moderation.
Yep. Daniel Nep asks, where are containers published on Akash run?
Containers published on Akash runs on the provider themselves. So containers, I don't know what containers published means. Akash doesn't publish containers. So you publish a container to a registry and you point Akash to pull the container from the registry, and a provider will pull that container from the data you provide. If that answers the question. That gives another opportunity. I love to see people build a Docker registry on Skynet. So that'll be really cool, I think, because it'll be a fully decentralized Docker registry that never was built. And I'm going to offer 1,000 AKT to anyone that builds it.
Okay, yeah. How do you imagine this? Like people using Akash and Skynet together. This is like,
there's so many use cases, right? Like I just described. Like storage and compute have been married for before you and I were born, right? So there's so many things you can do with storage and amazing use cases that you can do when you bring these together. Right now they're just you process on Akash and store on Skynet. That's really where we're seeing. And we need, so Akash does ephemeral storage. That means whatever you store on Akash only lives for the life cycle of the lease. Once the lease dies, your storage is gone. There's no guarantee. You might get it back, but there's no guarantee, right? You cannot rely on Akash to store your data permanently, but Skynet can, right? So ideally, the workflow would be something like, well, you have a snapshot of your database on Skynet, and you run your application on Akash. When the application boots, you pull that snapshot and you load your database using the snapshot from Skynet in your container on Akash, and periodically in a sidecar, take a snapshot. And there are tools, it's on my Twitter, there are tools on how to do that, how to pull that data from your MySQL and post that into Skynet, and do that periodically. And whatever you can do real time using a I guess can't use the typical database architecture terms anymore. Standby database, you can pull data. You can have a standby database and pull update them real time to Skynet. So you have almost real time backups that you never lose. And in case of a server down event, Akash has a beautiful event bus mechanism for you to write all those event handlers. In case of a server down event, make sure you can back up, and when you reprovision, make sure you can reprovision from the data snapshot that you can pull from Skynet. So that way you can have data stored on Akash permanently.
Right, you mentioned leaves and leaves dying. Can you elaborate on that?
Lease. So yeah.
Oh, yeah. Lease.
So in distributed systems, you almost never want to walk in with an assumption that things are going to run all the time. But you have to sort of design your systems for failure, right? Because nothing that runs, doesn't matter decentralized or not, is going to run permanently. And this fallacy of like, it never stops, I think is just wrong, right? So things fail almost all the time. And you have to design for failure. That's fault tolerant design. Fault tolerance means not avoiding failures. Fault tolerance is like tolerating failures, right? So, so most distributed systems architectures will, on Akash, since it doesn't give you managed services, nobody's sitting there managing service for you. If anything happens, it could be your application crashing, or it could be anything could happen in infrastructure. You're ultimately responsible for securing the data, right? It's a very powerful platform. So right now you have to like write these, redundant architectural systems in order to have a fully productive production grade application on Akash. In the future, that thing will get a lot simpler. But right now, it's so early. We just launched this platform like a month ago. You have to write these backup mechanisms, these redundant deployment mechanisms, this primary, secondary database sort of like architectures and the synchronization between them, all that stuff yourself.
Mm-hmm. And that might be the feature, not a bug, because no one wants to socially engineer somebody at Akash and access your day.
Yeah, we don't want to hold your data. Nobody, like, it's a decentralized system. So you have to really rethink how you use the system, and it's open source system, so you can build on it, right? There's no support. You don't call a number and people will give you support, right? It's so powerful that you can do anything with it. But that also means you have a lot of responsibility, just like securing your keys, right? Like, it's very similar to that. I mean, of course, you have to. I mean, there will be a market. In fact, we are actually putting groundwork for a more centralized service that leverages the power of Akash. And it's not a bad centralized service. That means it has username and passwords or like PII information. It still probably will use Akash keys for the most part. But you there's definitely a place for managed services, right? Like, you don't want to write these autoscalers yourself. You don't want to write these event managers yourself. But there's a market for it, and I think people should definitely look into it. If anybody's like writing this stuff, I'll personally use and pay for it. So we are seeing inherent problems that, not problems per se, but things that we can add on top of Akash that would be nice to use. I actually started working on a product called Mitra. Mitra means friend in Sanskrit. Akash, by the way, means sky in Sanskrit. So Akash, sky is where the clouds are formed, so that's how the name came. And Akash Net means Skynet. So I don't know how that happened, but it happened. So Mitra means friend, and Mitra is a tool that'll sort of do these like integrations for you. And first use case we're doing is a connecting handshake and Saya there. So when you can actually, this should be ready in a month or so. If you have an application running on Akash and you have a domain name attached to it, you can register that domain name automatically in Handshake. And in case of a fault tolerant event where the node kicks you out or provider kicks you out and your application goes to another provider and you get a new IP address, that IP address will again re-register back at Handshake. So you're not going to have any disruption in your user flow. So I'm really excited about that sort of like that tool, and that can be done in a decentralized way, right? That has to be.
That's neat. Where is the data flow taking place? Is that happening over?
So that's a bot
IBC,
running on Akash.
or that's no.
I eventually IBC. Right now, that's a centralized. It's a bot, right?
Sure.
That's where I was going. Ideally, that should be a decentralized flow, but we're not changing Akash. Is not going. It's a protocol, so it's very hard to iterate on. So I started this new project, a centralized, like a bot style project that can quickly iterate on these use cases. And once we learn from like user behavior for some of these use cases, we'll essentially put a proposal on how to bring that to a more IBC style interoperable transaction.
So, okay, that's really exciting because I imagine that once this system of protocols is fully mature, then like no one really would have any need to go through like a centralized exchange, for example. So like let's say in the Cosmos network, decentralized exchange is done, right? It's solved and it's seamless. The experience is great. And so if I could just log in with my handshake TLD in that and not have to provide anything else besides that to identify myself, and log in with that, go through Akash, like, and an IBC, enter into the Cosmos network, and now I'm able to do like just exchange and like compute just across this whole network without ever having had to touch some sort of custodian.
Oh yeah, 100%. Yeah.
Great.
I'm going to put the prototype in a centralized way first, but that eventually will be more decentralized, and that's a use case I'd love to see on IBC for sure.
Yeah, that's really exciting. Great. I'll take another question from the audience. Anmol Ratan asks, how do we ensure high uptime with shared compute? If a host decides to kick someone out, how do system ensure there is transparent failover? Is it container owner job to run services in hot mode?
Yes, good question. So how do you ensure high uptime, redundancy, right? And that's really the answer. Akash gives you a cost profile that's so lucrative that you can actually run highly redundant service and not take a hit on your wallet. And if the host decides, again, that if a host kicks you out, that is an event that's generated on Akash blockchain, so that sort of events are all transparent, and you get a notification. That means you also have to write a handler, a custom code right now to look for that event and reprovision the workloads. We may bring that reprovisioning back into the protocol, but like I said before, the protocol by design, we kept the decisions as little as possible, because we rather have the users determine how they want to handle a fault-tolerant event versus us handling it for them. It's like throwing a good error message versus us doing all this like extra stuff and you have no idea what's happening. It's not for the lack of like whether we want to build this handler ourselves, but I think giving a decoupling decisions from the core platform was very, very critical for the design of the system. So there are different, when it comes to like, yes, it is a container owner job to run these in a hot mode. But that also gives you an opportunity to design whatever deployment schemes that you want to run, right? Like, so when something goes down, you want to know why it went down, right? Rather than just spin up another service up, and you want to be able to put parameters or limits as to how much you want to scale, right? Maybe it went down because your application went viral. In that case, okay, actually go deploy multiple instances. But if it went down because of a disk space error or some other event, which could be a million events that could happen, you want to handle that accordingly. So giving the freedom to the user was critical in the application design, and that's why that's really how we think about when it comes to scalability. We think people are smart, and we don't want to make people's decisions on behalf of people, especially things like this.
Joseph Robinson asks, how does Akash handle short-term scaling needs for client applications?
I find it hard to answer generic questions like scaling and security. Short-term scaling needs, I don't understand what that means. What does short-term scaling needs mean? If you want to scale, I mean, scale is as limited. Like right now, Equinix is a big data center provider on Akash, and they're the largest data center provider in the world. If your application needs more data centers than Equinix, then you probably need to build your own data center. So short-term or long-term, I think Akash can handle it. It's really up to how many boxes you want, how many instances you want. You can define that, and you can scale accordingly.
Yeah, long-term, as Tesla data centers in the garage enter into the market, do you think we would no longer need large data centers like Equinix to handle the load?
No, we do, definitely do. They're completely different animals. The Tesla style will be more for GPU workloads, where you have more of a map-reduce style jobs, where you have input and output. You don't care about privacy. You don't care about security or things like that, because you're not hosting a financial database. But yeah, if you are hosting a healthcare database, you probably need a security with real like Navy SEALs at your at your doors, like underground for 100 meters or something like that. So you definitely need a big data centers, and there is a place and time for them. But if you look at where the world is going, it's mostly in a message in a machine learning and AI style workloads, because that's where a lot of the data is getting processed, and that's really where we want to see a lot of innovation happening. That's where the Tesla comes into play, right? Because it's just message passing from one GPU cluster to another.
Is this going to be like different tiers of services that's going to like cost different amounts depending on the criticality of the application?
Yes, exactly. And that's really the beauty of Akash, right? So very good point you brought up. Like today on the cloud, not every application has the same scalability and security needs. Just like how you see in Ethereum versus Cosmos argument, right? Ethereum, you have this shared security model and a shared cost model. Like if you want to maintain an NFT versus sending $1 million, you pay the same cost, which is stupid, right? Like, and same security, right? Like you don't need that sort of like homogeneous security and a scalability model. And we are seeing limits with Ethereum. Whereas Cosmos, you have this beautiful sovereign security model for individual chains, where you can decide how much security you want. Some chains will have enormous, the validator sets that are different from different chains, right? And the security budgets you give for these chains will be different from each chain. And Cosmos IBC brings these chains together, right? There's a lot of value in that. You look at Amazon, look at Akash in a very similar way. Different applications have different needs when it comes to security and scalability. And you, as the user or the developer, should have the freedom to choose what data center you want based on that profile. And that's where we really want to build out this audited attributes architecture really well. So you can filter out whether you want SOC compliance or HIPAA compliance, or you want, and these things can be verified on chain, right? These are just this compliance stuff. Or if you want to know who actually has physical access to your box, and that person who has access to the box, do they have a background checks, right? Like Amazon doesn't give you anything, right? Doesn't tell you who actually accessed your database. For all you know, that somebody's actually looking at your databases. And I'm not saying they are, but they could, and you don't even know about it. But what if you want a service that you have full data, where an auditor has access to the system logs, and they have access IP addresses, they have access logs, and they're like looking out for you, and they're transparent with you. And what if you want that level of scrutiny in a data center provider? You don't get that today on Amazon, but Akash, we want to make that happen, right? Different applications have different tiers, and you should maybe pay a premium. Sure, why not, right? If that's what you want. But opening up a marketplace and giving the freedom to the individuals to make the choice instead of a company choosing and giving a homogeneous service is where we're going. That's really what I was talking about, this Airbnb model versus the Hilton model. Hilton, yeah, you get homogeneous service wherever you go. But Airbnb, I was on a vacation with my family. I stayed in a beautiful villa with a swimming pool and like 5 bedrooms. And yeah, it's a premium than Hilton, but I had this beautiful like personalized service and all that stuff, right? I can only get that on Airbnb.
Right. I actually thought of something really, really interesting when you brought up the different tiers of services with like a full-on data center versus the Tesla in your garage, which is, I imagine that in the future, there's the only users of the like unused capacity in your Tesla is going to be either like a machine, right? It might not be like a human. So in that sense, I imagine that there's going to be high frequency trading bots that are going to be like algorithmically trading compute on like all these Teslas the same way. There's going to be like HFT algo bots across all of these different exchanges to arbitrage?
Well, HFTs, for them, it's really a latency game, right? So they are, I know friends that do HFTs, and they really fight for latency, in a sense, parts within the data centers itself, right? And there's this beautiful book called Flash Boys, which is highly recommend if you read that. And you look at, in their book, they even had to cut through mountains in a straight line from Chicago to New Jersey to get the latency. And people didn't have no idea why they were cutting through straight lines. And that's the level of optimization. I don't think they'll be running on Teslas. I think they'll be running on big data centers because it's millisecond latency game, right? You got to be faster than the other guy to front run, right? Like it's like putting your transaction in the mempool and out, how miners could effectively front run your transaction, right? It's like that. So I don't think Teslas will be running the HFT bots. I think Teslas will be mostly for machine learning, and their Teslas are really good. They're edge computers. That's what they do. They analyze your images in real time. That's what they're meant for, right? So I think unlocking the capacity is going to just open up a whole range of like opportunities, possibilities.
Oh, sorry. I think the better way to rephrase my question was: do you imagine people building bots to high frequency trade compute basically and arbitrage across all these different machines?
Of course, yeah. So we're working on futures as well, and it's still early design. I think opening up, creating a futures market for compute will add efficiency. Futures generally add efficiency to pricing. We're going to see, but futures also adds volatility to pricing. So, but through frequency, they effectively add efficiency, and volatility is actually good for pricing in some cases. But yeah, I totally imagine there will be high frequency trading for compute.
Okay. Yeah. Cool. That's super interesting.
Akash is computer marketplace. That's really how we think about these things, like an exchange for compute, a decentralized exchange for compute. Yeah.
Interesting. In the future, we'll be doing I don't know, what do you call that? DeFi dWeb.
Oh, it's the dWeb or the dCloud, right? Like
yeah, dCloud.
Yeah, dCloud.
Okay, yeah, very cool. So, we're coming up on the 1 hour mark. This has been just a super insightful interview. Thank you, Greg, so much. I have some very quick announcements, which was this unfortunately was the very last episode. Chris Goes, my co-host, is going to be joining with us. It was a beautiful journey, and I want to thank Chris for coming along this with me. Thank you to the audience for coming on live right now, and thank you so much, Greg, for being here with us. This was an excellent interview.
Thanks, Chjango. This was a lot of fun.
Yeah, and our next episode is going to be with crypto.com. That's going to be sometime in May, so wait for an announcement. Thank you, everyone.